All right, I'm seeing one person who is on the live right now. Just send me a text message. Let me know who it is. So we're gonna start as soon as a couple more persons join. We're going to go ahead with the stream. Um, we're just doing some trigonometry, and we're going to look at geometry, the parts of geometry that are needed in order to understand trigonometry better. So we're just waiting on a couple more persons to join, and then we're going to start off. All right, I see one viewer, so just send me a message and just let me know where you're joining from, who the person is. Welcome, welcome. All right, welcome. I see that someone has joined. Just send a text in the chat. Let me know who you are, where you're joining from. Welcome, welcome. All right, I'm gonna start. Not sure if anyone is hearing me. If anyone is here on the live, um, if you're here, just send a text. All right, so I can know. But anyway, I'm gonna start with the lesson that I have prepared. All right, I'm gonna start. Not sure if anyone is hearing me. If anyone is here on the live. Okay. All right. So we're looking at geometry, the parts of geometry that are needed for understanding trigonometry. So we're looking at both geometry and trigonometry in this lesson. All right. So geometry, a line is a straight path that extends infinitely in both directions. So this is a line here. And this line, you can see the arrows pointing in both directions. So it extends all the way in those opposite directions to infinity. All right, and these are some little definitions and things that you should know in order to be able to do geometry well. The line segment is a portion of a line with two endpoints. So we can see these 2 points here. These are the endpoints of the line, and the line segment is right here. So it does not continue to infinity on both opposite sides like the line, but it is just a part of a line, the line segment. It has two endpoints. A ray has one endpoint that extends infinitely in one direction. So this is a starting point, and then this arrow shows that the ray continues to infinity. Now rays are important because angles are formed when two rays share a common endpoint. Alright, so for example, we have these two rays here, one ray here and another here, and these two rays, they form an angle. Now this is a 90-degree angle, right? So this is a 90-degree angle here formed by the ray, and it's also called a right angle. All right. For these other two rays, they are forming an angle that is less than 90 degrees. You can see that the space that is here is smaller than the 90-degree angle and that of the 90-degree angle. And by the way, we're talking about the right angle. There's a special symbol that is used to represent the right angle. So we have a special symbol that's used to represent it here. And let me just get my pen. So this symbol here is used to represent the 90-degree angle. All right. Yeah. So that is an angle that measures 90 degrees. Then this angle here would be less than 90 degrees. All right. But it's not opened as wide as this one here that's 90 degrees. So this angle that's less than 90 degrees is called an acute angle. All right. So it is acute. And remember that this angle is a right angle. Now this right angle is important because it forms a special kind of triangle that is a right angle triangle. We're gonna look some more into that. So this is a right angle which measures 90 degrees. And the acute angle, remember, measures less than 90 degrees. Now the angle below that is an obtuse angle. It is obtuse because it is more than 90 degrees but less than 180 degrees. Alright? And a straight line angle is the angle that forms a 180 degree angle. Straight angle. Like this one. That straight angle there, it would measure 180 degrees. Alright? So this will be called a straight angle. Alright, so we always hear that angles on a straight line measures 180 degrees. So this is it right here, the straight angle which measures 180 degrees. So moving right along, right, bear those in mind. Moving right along. So this is our straight angle, 180 degrees. And then we have a complete angle here that goes all the way around, and the two rays meet after going all the way around. And this is a complete angle. It measures 360 degrees. All right, it's 360 degrees. All right, so here we have three rays. Two of them are parallel. So these two here are parallel, and the symbol shows that both lines are parallel. All right, and then we have a transversal. This line that goes across the two parallel lines is called a transversal, that cuts the two parallel lines. So we have angles being formed here. Well, along the parallel line, you will have a straight angle which measures 180 degrees, and another straight angle here. Because these two lines are parallel, all the angles at the top here, and all the angles that are formed along the first parallel line here will match with all the angles that are formed along the second parallel line. So if we call this part angle A and make this angle B, and we have angle C and D below, and we could have here angle E, F, G, and H. So angle A here would match with angle E. So angle A is equal to angle E. They're both formed on parallel lines. And you can go ahead and do some more matching. Angle B would match with angle F. So B equals F. So they would be the same size as angles. Angle B would be the same as angle G. And there's some other angles that are equal to, but we're going to look at them in a little bit. Angle C will be equal to angle H. So these angles are all formed along two parallel lines with a transversal cutting them. So the angles that are in the similar position, they are the same in terms of their sizes. All right. But also angle G is equal to angle E. Angle G is equal to angle E. And if G equal E, that means that it's also equal to A and B, right? So all these four angles would be of the same size. G, E, D, and A. And angle F and H would be equal to angle B and C. So angle F would be equal to angle H, which would be equal to angle A, which would be equal to angle D. All right, send me a message in the chat. Let me know if you're getting it so far. It seems as if I wasn't sharing my screen earlier, but you're supposed to be seeing it right now. All right. All right. So I see that there's one person there. Just text your name. Let me know who it is. Welcome, welcome. Let me know if you're understanding what we're doing so far. As we were saying, it seems as if the screen wasn't being shared earlier, but we're just talking about the two parallel lines there that is cut by a transversal, and when the transversal, okay, when the transversal cuts the two parallel lines, we have similar angles being formed. All right, angles that are equal to each other being formed. So we can see that along the two parallel lines, angle A would be equal to angle E. All right, um, angle D would be equal to angle G. Angle B would be equal to angle F, and angle C would be equal to angle H. And then we notice that angles G, E, A, and D are all equal, and angles F, H, A, and D are all equal as well. All right, good. So let us continue. All right, and then one other thing, um, we'll have to make note of what we sometimes refer to as a Z angle. So this right here, you see that Z? We sometimes refer to it as a Z angle. And on the so-called Z angle, the interior opposite angles are the same. So the same way would be equal to H, F, H, B, C, F, H, B, C. All right, if I make a slight correction here, it's F, H, B, C, that should be right here. F would be equal to H, which is equal to B and equal to C. Alright, so F is equal to H, which is equal to B and equal to C as well. Alright, so this for this Z angle here, the interior opposite angles are the same. So as we already know, angle D would be equal to angle E. These are interior opposite. Alright? And this is very important for us to know when we're doing things like the angle of elevation and angle of depression. It's very important for us to recognize that these two angles are the same. Alright? So we can do some calculations with that. So let's move down to our triangle here, and this is a right angle triangle because you can see here that a 90-degree angle is formed at this corner. So this is a right angle triangle. So this is a special kind of triangle, and the sides have special names. Alright, so I'm gonna put the symbol theta here to represent an angle that would be formed right at this corner. So the side that is facing the reference angle. So this angle that we mark here is called the reference angle. The side that's facing the reference angle would be your opposite side. So as we said, the sides of the right angle triangle have special names. So this would be called our opposite side because it's facing the reference angle. So whichever angle we're using as our reference angle, the side that is facing it is called the opposite. Then the side that is facing the 90-degree angle, which is our longest side, is called the hypotenuse. So this is called the hypotenuse. It's the longest side, and it's the one that is facing the 90-degree angle. Try to take note of that. Sometimes students get their information mixed up as to what the different sides are. So the hypotenuse faces the 90-degree angle, and it is the longest side. And that makes sense because on the triangle, the 90-degree angle would be the widest angle. So the longest side would be the one facing it. Then the side which has the two angles beside each other, the reference angle and the 90-degree angle, this line joins both of them together, and that's called the adjacent line because it has two angles, one on either side. So it's called the adjacent. All right. It has a 90-degree angle specifically and another angle on either side. So it's called the adjacent side. And it connects the reference angle. To be specific, the reference angle, the angle we're using, and the 90-degree angle, the line that joins the reference angle and the 90-degree angle is called the adjacent side. All right. Now, in order to find missing sides and missing angles and work out stuff with the right angle triangle, we have what we call the trig ratios. So we have three ratios, and you must have heard of SOHCAHTOA. That's a little thing we make up to help us to remember different the different equations that we use. So I'm gonna break them down, and hopefully I can give you some tools that can help you when you're doing calculations using the trig ratios. All right. The trig ratio is used when you have one side for the right. It's used for the right angle triangle specifically. When you have one side and a given angle, or you might have two given sides, you can use the trig ratios for that. All right. So if you have a given side and a given angle, or if you have two given sides, then you can use the trig ratios. All right. Cool. All right. So for SOH, sine is equal to sine of the angle. So we can write sine theta to represent the angle is equal to opposite over adjacent. Opposite over hypotenuse, sorry. So sine theta is equal to opposite over hypotenuse. So we're just going to write the first letter to represent the side that we're referring to. So sine theta is equal to opposite over hypotenuse. Cosine of the reference angle, or theta, is equal to adjacent over hypotenuse. And tan theta is equal to opposite over adjacent. So let's look at sine, for example. If you have the angle, so the equation has three variables: sine of the angle, and then opposite, and the hypotenuse. So if you have two of the variables, for instance, you have an angle and you have the hypotenuse, then you can use this equation, all right, to solve for the opposite side. So if you have two parts of the equation, then you can solve for the third part, all right? With the cosine, if you have, say you have the adjacent and the hypotenuse side, you can solve for the reference angle. Or if you have one of the sides, whether it's the adjacent or the hypotenuse and the reference angle, then you can solve for a missing side. But you have to know when to use these ratios. So if you have, there are three variables. You have the angle, you have the adjacent, and the hypotenuse. You must be finding something that is within these three parts of the equation, these three parts. So for example, you have the missing angle, the hypotenuse side, and you're trying to find it, x. But you get the length of the adjacent side, and you have the angle. Then naturally you would use cosine, because cosine have those elements, right? It has the adjacent you're trying to find, or the hypotenuse that you're trying to find. It has the length of the adjacent side, all right, and you might be given the angle, all right? Or you might be given the angle, the size of the angle, and you might be given the hypotenuse, and you're finding the adjacent. But this one would have this equation, this ratio would have all the elements that you need. So you have to know, first of all, what the name of the sides are, and then you have to look at these three ratios to know which one you need to use. Let's do a quick example. So for instance, we're trying to find a missing side, and we put a x here. This is the side we're trying to find. We have the right angle here and our reference angle right here. All right, and we say that this is 40 degrees. And we have 4 centimeters here. Now, which one of the ratios would we be using? Send me a text in the chat and let us see what you think. Which one of the trig ratios would we be using? We know that the sides of the triangle, we have the hypotenuse here. We have the opposite side here, which is facing the reference angle. And we have the adjacent side here, which is 4 centimeters. As it joins the reference angle and the 90-degree angle. So this is the adjacent side. Which one of the trig ratios would we be using? What do you guys think? All right, which one are the trig ratios? Anybody? All right, so if you're saying that we're using tan, then you would be correct, because we have the opposite side. We're trying to find the opposite side, so that's a part of what we need. We have the length of the adjacent side, and we have the reference angle. So tan is what we would need. We have this is involved in the equation, the opposite side, the adjacent side is involved, and only tan as the opposite and the adjacent side together as part of the equation. So we definitely would choose tan theta. All right. So I just want you to note that. Very important when using the trig ratios that you understand which one of the trig ratios to select. All right. Hope you figured that part out okay. All right, so we're going to go ahead and work this out. So one of the things that can help you, sometimes you need to know to transpose, but you can double check your transposition using this tool here that maybe a teacher had given you. Very important that you learn how to transpose, but to check if you have transposed correctly, you can use this little tool here. It's called the magic triangle. So just like how the equation is set up, tan theta equal opposite over adjacent with the opposite side in the middle, then we would put the O for opposite right at the top of the triangle here. Tan of the angle goes over on the left side. So tan of the angle would go there, and then the adjacent side goes on the right hand side. All right, so this is just a tool that can help you to figure out how to transpose with any equation that has three parts. All right, so what we need to find now is the adjacent side. So if we cover over the adjacent side, we take that, we imagine that we have taken this part out that says A. What would we be left with? We would see that if you go ahead and just cover A with your finger on the screen, that side that says A, this side of the magic triangle, you'll see that you would be left with opposite over tan theta. You see that? Right? So that is that, and then if you cover the opposite side, which is the side we're trying to find now, if you go ahead and just cover the opposite side, you'd see you'd be left with tan theta multiplied by, because when these two sides facing each other, we put a little multiplication sign in between to show that we multiply when we are left with these two variables. So the opposite is what we're trying to find, so we cover that part, and we're left with tan theta multiplied by the adjacent. So this is the equation that we need. So the opposite side, when we take that out, we'll be left with tan theta multiplied by the adjacent. All right. So this is something that can help you with your transposition to double check if you have transposed correctly. Okay, you have to learn to, this is not a shortcut because you must learn how to transpose, because in doing other math problems with more than 3 variables, this won't help you so much. This triangle won't help you so much. So you have to learn how to transpose. All right. So let's go ahead and solve this. We have tan 40. So we're just plugging in the values for each variable that we can find. So tan 40 here multiplied by 4. You can work that out in your calculator. In your calculator, you can just put in 4 tan 40, 4 times tan 40, and see what answer you come up with. 4 times tan 40. And just send a text with your answer in the chat. Anyone? All right, if you get an answer that you rounded off to 3.36 centimeters, then you would be correct. All right. So the opposite side would be equal to 3.36 centimeters. All right, so we use this equation using our magic triangle. All right, let's look at another one where we have to find a missing angle using the trig ratios. I want you to be able to see what we have on the screen here. So let me just do it on this side. So this is the angle we're trying to find, and we're going to put our x there. We need this angle, and then we have 5 centimeters for the hypotenuse, and for the opposite side we have 3 centimeters. And we're trying to find this angle here, or reference angle. So what are the parts of the triangle that are, with the names of the sides that are involved in this problem? We have the opposite and we have the hypotenuse. Now, which one of the ratios have both opposite and hypotenuse? Which one? So we have the opposite here, and we have the hypotenuse. So which one of the trig ratios having both opposite and hypotenuse together? Well, if you said it's sine, then you are correct. All right, so sine as in both the opposite and the hypotenuse. All right, so let's look at our equation would be set up. Just using our magic triangle to fill in these variables into the magic triangle. We know that, notice that the opposite side, that's right here at the top of the equation, so we can just put that right here. So, and then sine theta is over to the left hand side, sine of the reference angle. Put that in to our multiplication sign right here, because we'll multiply. If we're left with these two, then we'll have to multiply. Then we have the hypotenuse. So we're trying to find the angle that is missing. We're trying to find this angle here. So we cover sine of the angle, right? And when we cover that, we'll be left with opposite over hypotenuse. So the equation is the same. So we mark out this or cover it, the h for hypotenuse, and we'll be left with O over sine theta. You see? So this triangle is can be very useful to you to just double check your transposition. So sine theta is equal to opposite over hypotenuse. So we're gonna plug in our values. So the missing angle, that's angle x. So we can write sine of angle x is equal to the opposite side is 5 divided by the adjacent side, which is 3. So what we do this now, we divide 5 by 3 and we keep that answer on our calculator, right? So we don't want to round off and write down anything and round off too early in the problem. So we just divide the 5 by the 3 and we keep that on our calculator. Because x is going to be equal to the sine inverse and on your calculators you'll see sine inverse looking like this, sine to the negative 1. So it's sine inverse of 5/3, and you'd have the decimal value for 5/3 on your calculator when you divide 5 by 3. Right? So you'd find the sine inverse of that. All right? So usually you press shift or second function and then press sine, because the sine inverse is usually the second function for the sine button on your calculator. The sine inverse here, I can't explain to you why we use sine inverse, because really when you have the x here, we have the sine here, we want to find what x is, and we have sine multiplying the x. So what we do now is actually divide both sides by sine. We divide this side of the equation by sine and the other side by sine as well. So what we have left is something looking like this. X equal 5 over 3, and that's divided by sine. So we can write this another way. We can write it as x equals 5 over 3 divided by sine over 1. And you'd know from dividing fractions that when you're dividing a fraction, you leave the first fraction, so you leave the 5 over 3, change the division sign to multiply, and then flip the sine over 1 to 1 over sine. So what you'd have is actually 5 over 3 times 1 over sine, because you're gonna flip this, right? So you'd have 5 over 3 divided by 1 over sine. And then from your laws of indices, let me go back to that page, sorry. Things just jumping on. Track here a little bit. Yeah. This is where we need to be. So 1 over sine. So you'd have 5 over 3 times 1 over sine. And then we know from the laws of indices that 1 over a variable or a constant. So 1 over anything would be equal to the inverse, negative 1 of that. So 1 over sine, if you're writing it in index form, it would be equal to sine to the negative 1. So that's how we get the sine inverse. Alright? So 1 over sine is equal to sine to the negative 1. So this, what you'll be left with is sine inverse multiplied by 5 over 3. Right? If you follow that pattern, those steps that I showed you. So that is where the sine inverse comes from. It's actually the inverse of sine. We're using sine to divide 5 over 3. So we use that on the calculator. So it will be sine inverse times the answer for 5 over 3. Alright? So 1 upon sine is the same as sine inverse. Alright, so let's see if we can get the solution to that. Sine inverse 5 over 3. The 5 divided by 3 would give us 1.666666667. Alright, but we don't round off yet. Better not to round off until we reach the end of the problem. So we just find the sine inverse of that number. Opposite over hypotenuse. Sorry, it's not 5 over 3, but actually 3 over 5. As the opposite side is 3, over the hypotenuse 5. My mistake here, that's why you might be getting an error. It's actually 3 over 5. So the 3 is the opposite, and the 5 is the hypotenuse, and it says opposite over hypotenuse, right? So it would be 3 over 5. Not 5 over 3. So the opposite side is 3 over the hypotenuse, which is 5. 3 divided by 5 would give you 0.6, right? 0.6. And sine inverse 0.6 would leave us with what? Sine inverse of 0.6 that would give us 36.869, or we can round that off to 36.87 degrees. All right, so this angle here would be 38.87 degrees. That's the 2 decimal places. .87. All right, so, and that's degrees because it's an angle, right? So we put our little mark for degrees there. Well, we've gone over well over 1 o'clock. It's now 1:17. All right. We thank the 2 persons who joined. Oh, I should not see the screen. All right. Well, sorry about that, guys. I didn't know my screen come off. So that's the screen there. All right. So this was my first live. A bit nervous, and then whenever I get a lot of people coming on, but I expected to see a couple more persons, but we're grateful for the 2 that came on. Yeah, so that is it. That's it from us, and we're gonna end the stream, and hopefully next time we can do a lot more. All right, so take care and bye.